Healthcare systems are rapidly integrating third-party AI to streamline clinical workflows. But standard IT security scanners are built to catch static code vulnerabilities. They are blind to machine learning risks like algorithmic bias, unpredictable outputs, and subtle training data leaks. To safely evaluate, legally bind, and validate these tools before they ever interact with patient data, organizations need a specialized defense system. Relying on standard procurement processes leaves your network exposed. Following the framework established by the Health Sector Coordinating Council, you must implement a dedicated 7-phase AI lifecycle to guarantee both patient safety and data privacy. The process begins with Phase 0, use case justification. Before committing resources to vendor evaluations, you have to define the specific problem and determine if an AI solution is actually required to solve it. Next, look at this 4-tier risk pyramid. You must classify the AI's impact on patient safety across these levels. A basic administrative scheduling tool sits at the low end, while autonomous diagnostics carrying life or death consequences occupy the critical peak. Once the impact is classified, you move to Phase 1, due diligence. Here, you conduct an AI-specific governance, risk, and compliance assessment. This requires interrogating the vendor on the origins of their training data and their bias mitigation strategies. You must also map their fourth-party dependencies, identifying if they rely on external foundational models hosted by other companies. Skipping these initial vetting phases leads to adopting technology simply for the sake of innovation, while forcing your organization to absorb hidden supply chain vulnerabilities. In Phase 2, contract negotiation, you address accountability. Standard software licensing agreements offer almost no protection when dealing with AI tools. You must negotiate AI-specific business associate agreements, or BAAs, that explicitly define who owns the data and the derived insights. Pay close attention to this specific clause. You must strictly prohibit the vendor from using your protected health information to train their shared or public models without your explicit consent. By securing an AI-specific BAA, you transform a standard vendor relationship into a legally enforceable shield for patient privacy. Phase 3, implementation and validation, serves as the most critical barrier between a vendor's promise and patient contact. Here, you conduct AI threat modeling in a closed sandbox environment. You test for behavioral vulnerabilities using industry standards like the OWASP Top 10 framework for large language models. Inside this closed system, you test for adversarial attacks, specifically looking to see if prompt injections can force the model to disclose sensitive data. You also check the tool's clinical accuracy. By comparing the AI's sandbox recommendations directly against internal clinical expert baselines, you prove whether the system actually works in your specific environment. Next, verify that human override capabilities function correctly. Clinicians must be able to reject recommendations to prevent clinical over-reliance and alert fatigue. Before granting production access, you have to enforce mandatory role-specific training, so your staff knows exactly how to interpret and, if necessary, override these outputs. Rigorous sandbox validation proves both the tool's clinical safety and its operational integrity long before it ever affects a patient. Phase 4 focuses on ongoing monitoring. Unlike traditional software, AI accuracy degrades over time as the real-world data it processes changes. This chart shows model drift. To catch it, you need dashboards that continuously track performance drops and identify any emerging demographic bias in the outputs. During this phase, you also have to watch for vendor software updates, which can easily override your configurations and reset the system to vulnerable default security settings. When issues do occur, Phase 5 dictates your incident response. AI failures rarely look like total system crashes. They manifest as gradual degradations or clinical hallucinations that are difficult to spot. Your contracts must define exact service-level agreement timeframes, forcing the vendor to step in and assist with forensic investigation and model rollbacks when performance drops. Finally, Phase 6 covers end of life. The exit strategy for an AI system must be planned during the initial contract phase, not when the vendor discontinues the product. You must require vendor certification of data destruction, ensuring your organizational data is securely wiped and not permanently embedded within the vendor's model weights. Continuous post-deployment vigilance is exactly what keeps an AI tool functioning as a safe operational asset rather than an unmonitored liability. By adopting this 7-phase lifecycle, you systematically transform a high-risk vendor pitch into a secure, legally bound, and clinically validated asset. You secure 3 distinct victories: shielding your protected health information, enforcing vendor accountability, and proving the tool's safety in a controlled sandbox. To get started, download the HSCC Third-Party AI Risk Guide and immediately run your existing AI vendors through Phase 0. In healthcare, AI security is not a one-time software purchase. It requires a continuous, verifiable commitment to patient safety.